Today, I will be showing you how to create a quick grains recipe using Spotlight and how to catch missed features when your initial Spotlight grid doesn't collect all of the grains within an image. Now, this can happen if you do not use custom seed points, as the density of the grid can potentially not have any points on every single grain, similar to what we will be seeing in this case. So, first, we want to go in and create our grid. We'll be doing a pretty high density. And for our scale, we want to select auto. We're selecting auto since there's a large amount of deviation within the grain size on this image. So auto will allow Spotlight to select either a scale of 1, 2, or 3 as it would best fit the image. Now, for this initial pass, we won't be collecting all of the grains. If we increase the density to an extremely high amount, there's a possibility, but as we can see here, some of the smaller grains have been missed. Our initial segmentation is very, very good, but we can do better. So we want to set this as our first memory image. After that, we want to go in and invert. Now that we have this inverted layer, we can see that the missed grains are a little thicker than some of the boundary lines, right? So a good way to get about this would be to erode. We want to do an erosion of a depth of 10. Now we have some seed points. You can add as many Spotlight steps as you want to a recipe, as it is fully modular within MyPar. It is the same thing as any kind of morphology step, segmentation step. It's an unlimited amount. Now we set this as our companion image. Then we can go in and use Spotlight on this companion image. Now we want to use boxes with a score filter of a little higher, around 55. Now that we have those missed grains, we can press accept, set this as our companion image, call our first memory image, and then all we do is press union. Now this fills out some more of these grains that we've missed. We've selected almost all of them. I'm very confident in our selection. However, for a full analysis, we need to make sure that cases like this, we need to do a light separation and some rejection of these smaller features. So we would go in and do a quick separate features. For the maximum line length, I'll set it pretty low, 20 pixels, and a separation of 9. This will allow this grain to become independent. This is happening all across the image at the same time. And in order to get rid of these smaller feature selections, these artifacts, we can go in and reject feature based on size. This will give us better borders around our grains with an expansion and a decrease of this boundary area. So we would go in and do a quick clean boundaries. A thickness of 1 should be all right. And now I'd say you have a very good segmentation. Now, what we need to do is to remove any grains that are touching our scale bar and any grains on the boundary of the image itself. Those grains are incomplete, and any kind of area calculation for them will throw off the data and will be inaccurate. So we set this as our second memory image just to make sure we have it saved. In order to find our scale bar, we can go in and call our original image. Using our dropper tool, gives us any kind of pixel info on an image. Go in and we see that the pixel value is 255. So I can just do a quick basic threshold at a value of around 254. Right, that'll give us a selection of just our scale bar. So, real quick, for posterity, you do a quick relative size filter to make sure that we only select the one largest feature, which should always be our scale bar. Now we can fill all holes in order to get our selection a little more square, and dilate to a depth of around 10. Now that we have this selection of our scale bar, we can set our companion image as this, call our second memory image, and keep exclusive features. Right, we can see this removes anything that is touching our scale bar. Now the last step would be to go in and remove our edge features. Now we can go in, check our outline. Does a very good job on getting the grains. And now we have a robust recipe that should work for any types of images that were taken in a similar method to this one. In order to get our data, we can set this as a layer. Go into our measure features and select any of the options we have. Additionally, we can add custom measurements using our own formulas that we can input into the software. But for this specific scenario, all I want is area and add. Now, we can do a quick visualization and see exactly the area for each of our grains. All of this done in 22 steps. Have a good day.